Section B, question 9, which alkene shows EZ isomerism? 2,3-dimethyl-butene, methane, ethane, propane, butane. Carbon-carbon double bond, second carbon. 2,3-dimethyl-butene. So methyl group here, methyl group here. H, 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 H. Will that show EZ isomerism? No, because actually if we put the CH3 here, which it can be, H here, well that's completely symmetrical, isn't it? CH3 is H, CH3 H, 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 H. So no, that won't show EZ isomerism. 4-methyl-pentuene, methane, ethane, propane, butane, pentane, second carbon, 4-methyl, 1, 2, 3, 4, methyl group. And there we go. So if we actually draw this out like this, we've got CH3. We've also got a CH, CH3, CH3, and we've also got CH2, four methyl pentuene, methane, ethane, propane, butane. Yeah, it's going to be that. B. One second, guys. Yeah, because we've got CH, CH3, CH3H, H2. And the rest of them don't have two different functional groups on each carbon. That's why, and obviously for EZ isomerism we need a chiral carbon, a carbon with 4 different groups attached to it, whereas none of these have it, because some of these have a H and a H here. Well, that's not different. But only 4-methyl-pentuene has it. So you'd probably want to draw it like carbon-carbon double bond and then do it like that. A compound contains 40% that, 6% that, 53.3% of that, which could be molecular formula. So we need to find out the moles of carbon to hydrogen to oxygen. I'm just going to put on my calculator. It's going to be 40 divided by 12, 3.333, 332. Hydrogen is obviously 6.7 ml of hydrogen. It's just 1. Oxygen, 53.3 divided by 16, 3.33125. So we're going to divide by smaller ratio, 3.33125. And we don't need to even show the working out. It's one marker. We just divide by smaller ratio. So we get 3.33 divided by 3.33125. We get 1, 2, 6.7 divided by 3.33125 to 2 to 1. Well, all of these carbons have 2. That's carbon, hydrogen, oxygen. All of these have 2 carbons, so we need to times that by 2. So we get 2 to 4 to 2. So it's going to be C2H4O2. C. We're driving a car, legal limit for that is 8 grams per centimeter, 100 centimeters cubed. What's the concentration? First thing we find out moles. Moles equals mass. We need to convert that to grams, so it's going to be 0.080 grams divided by 1000. 123. 0.080 123 divided by 46, the amount. And we also know moles of concentration and volume. Concentration is equal to the moles, which I'm going to work out right now. .739 times by 10 to the power minus 3. Moles concentration, volume concentration is moles divided by the volume, which is 100 centimeters cubed. We want moles per dm minus cubes per meter divided by 1000, so 0.100. So my answer divided by 0.100 should give me 0.0174, which is same as 1.74 times by 10 to the power 12 minus 2. So therefore the answer is B. Which is propagation step with the chlorination of methane? Well, already I can eliminate that one because that's a termination step. I'm looking for propagation step. Termination. Chlorination of methane. When have you ever seen a hydrogen free radical? That's incorrect. So it's either between B and D. Well, B, chlorination of methane. What is methane? CH4. The answer is D. Because in B we form the hydrogen free radical, which we're not supposed to form. Which compound is not formed by reacting 3-bromo-3-methylhexane with warm ethanolic potassium hydroxide? So if we warm that with warm ethanolic potassium hydroxide, so that tells me, just that region tells me that it's elimination. Elimination. Reaction mechanism. Elimination mechanism. So this is a lot harder than I thought, because hopefully I was hoping one of them are an alcohol, so it can't be that because that would be by nucleophilic substitution or by elimination. But in this case, all of these are alkenes. So 3-bromo-3-methylhexane, methane, ethane, propane, butane, pentane, hexane. Methane, ethane, propane, butane, pentane, hexane. 3-bromo, methane, A, B, C, D, yeah, 3-bromo, Br, 3-methyl. So they're both in the same. And what will happen is that, because it's elimination, I have a double bond, and the Br is going to leave, and so we're going to have water. We can either have a double bond here, obviously the methyl group here, or probably a methyl group here. So 1, 2, 3, 3-methyl hex. Two ethyl pent-guanine. That could be formed. 3-methyl hex-guanine. 1, 2, 3-methyl hex-guanine. No, because then the carbon double bond would be here. That's not possible. So that can't be formed. 3-methyl hex-2ene, yes. 3-methyl hex-3ene, yes. Carbon double bond can be here. So B is the incorrect compound that cannot be formed. Question 14. Questions 14 to 16 refer to the reaction of 1-bromopropane with solution of potassium cyanide aqueous ethanol. This is when nitriles are formed by reacting halogen alkanes with cyanide. So what is the organic product of this reaction? I just said nitriles are formed, so it's going to be a nitrile. Well, let's just go through the mechanism. Actually, just get an exam, ask for a piece of scrap paper, and then just go quickly through the mechanism. So, methane, ethane, propane, 1-bromo. Methane, ethane, propane. Partial positive, partial negative. Potassium cyanide, C triple bond N, lone pair of electrons, yes, attached carbon, CBr bond breaks, and we form this CN H, and the lone pair of electrons Br minus is left there, and it'll probably bond with the potassium later on, but that's not necessary. So what is this? Well, like I said, it's a nitrile, so it can't be an amine, it can't be amine. It's either propane nitrile, butane nitrile. Most people say propane nitrile, methane, ethane, propane, but that's a carbon in of itself. So it's methane, ethane, propane, butane nitrile, not propane nitrile. I feel like that's the biggest mistake for this question, but the answer is butane nitrile, which is the correct mechanism for this reaction. I've just gone through it. Lone pair of electrons, C triple bond N. Well, obviously in this case it doesn't have C triple bond N, but the CN should be negative. So it's not going to be A and it's not going to be B because the CN with lone pair of electrons is not negative. So it's either B or D. And if we look at B, lone pair of electrons, attacks carbon, positive, CBr bond breaks. Yes, whereas this case, what's the difference between, oh, the lone pair of electrons in this case is on the nitrogen. That's false. Lone pair of electrons should be on the carbon. So the answer is B. CH3, CH2, CH2, Br, lone pair of electrons, Cn minus, attacks carbon, CBr bond breaks. The reaction of 1 bromopropane and 1 chloropropane with potassium cyanide aqueous ethanol occur at different rates under the same conditions. Which row correctly shows the compound that has a faster reaction? The correct rules for this: 1 bromopropane and 1 chloropropane. Bromo and chloro. Faster reaction. 1 bromopropane, as the CBr bond is weaker than CCl. Well, in this case, for CBr bonds and all of that, what topic is this? Yeah, okay, so there we go, got it. We've got CF, CCl, CBr, and I actually really like testing this as well. So you do need to know the CF, CCl, CBr, CI. And there's a faster substitution downwards, because the bond enthalpy decreases. The bonds are getting weaker. So using this logic, 1 bromopropane, well, that's the CBr bond. The CBr bond is weaker than the CCl bond. That is true, and that's why it's got faster reaction. Yeah, that's absolutely true. Whereas with the rest of them, CBr stronger than CCl? No, it's clearly not, because it's lower down the groups in this case, so it's going to have a lower bond enthalpy, a faster substitution. CBr bond weaker than CCl? Yes, it is, but then how does that explain why 1 chloropropane has a faster reaction? It would surely be C1 bromopropane which has a faster reaction, because CCl has a higher bond enthalpy than CBr, so therefore it would have a slower rate of reaction because slower substitution. And CBr bond is stronger than CCl. That's absolutely incorrect. It's lower down, so it's, bond enthalpy decreases, weaker bond. So yeah, so it's weaker, not stronger. Which compound has a molecular formula that is different from the others? Molecular formula that is different from the others. Well, for this one, they've all got 4 carbons, so we can't really rule that out. Now, because they've all got carbons, it's usually CnH2n plus 2. But now we need to look at the double bonds, and for every double bond, we minus 2 hydrogens. In this case, molecular formula is going to be CnH2n. Minus 2 we get 0, H2n plus 0, minus 2, H2n minus 2, because we've got 2 double bonds. In this case, we've got 1 double bond. 1 double bond. So what's the molecular formula going to be? CnH2n plus 2 minus 2, so it's going to be CnH2n. In this case, we've got no double bonds. And it's a cyclic thing that reduces the number of hydrogens by 2. This cyclic thing reduces hydrogens by 2, so that's also going to be CnH2n. And in this case, we've got 1 double bond. So this CnH2n plus 2, because it's got double bond, 1 double bond, therefore lose 2 hydrogen atoms, so it becomes CnH2n. So therefore that is CnH2n. That becomes CnH2n. Subtract 2 hydrogen. So D is CnH2n, C is CnH2n, that's cyclic alkene, reduces the hydrogens, 2 hydrogens. So B is CnH2n, because it's got 1 double bond. A is CnH2n minus 2, because it's got 2 double bonds, therefore A has a different molecular formula, has a molecular formula that is different from the others. 18. Which compound reacts with hydrogen bromide to give 2-bromo-3-methyl-butane as the major product? Carbon-carbon double bond, we've got CH3, CH3, CH, CH3, 2-bromo-3-methyl. So the bromo is going to be on the second carbon, right? So it's going to be D. CH32 CH double 1 CH2. And this I would recommend drawing them out, and obviously, but that'll take quite a while. And it's already 18 or 19 minutes long now, this video. We'll just draw them all out and you should be able to find them out. Which one will give you the major product. Which statement is not correct about the industrial production of ethanol from ethane at 300 degrees Celsius? Reaction catalyzed by an acid. That is true. Yeah. Phosphoric acid, I believe it is. Acid catalyst. The reaction has 100% atom economy. Or we form one product. So that is true. An increase in temperature decreases the equilibrium yield of ethanol. A forward reaction, that's negative, so that tells me that forward reaction is exothermic. So if we increase the temperature, it's going to shift to the side, the endothermic side, to oppose the increase in temperature, hence decreasing the temperature. So it's going to shift to the left hand side, and therefore it's going to decrease the equilibrium yield of ethanol, which is on the right hand side. And increase in pressure, increase the value of Kc. That is absolutely false. Only temperature can affect. So sometimes we do multiple choice questions. A lot of the times, actually, you just need to look at all of them first before you look at all of them. Before you look at them individually, because if I just looked at that immediately, I would have known that's incorrect, and therefore I would have got the mark pretty quickly. instead of going through each one, because I know only temperature can affect the value of Kc. Which statement about the use of a catalyst in a reversible reaction is correct? The activation energy for the reverse reaction is increased. The equilibrium constant increases. Like I just said, only temperature can affect the value of Kc. Only temperature can affect the value of Kc. So B is definitely wrong. So that's not going to be it. A is definitely wrong. Activation for reverse reaction is decreased, not increased, if anything. And C, the rate of reverse reaction increases. That is true. However, what I would think, a lot of students would think, is that in the mark scheme, a lot of the time the use of catalyst increases the rate of forward reaction, increases the rate of forward reaction and reverse reactions equally, hence no effect on equilibrium yield, right? That is true. However, it still increases the rate of the reverse reaction. It's just saying which one's correct. Does it increase the rate of the reverse reaction? Increase the rate of forward reaction and reverse reaction, but it does increase the rate of the reverse reaction, so that is true. Enthalpy change for forward reaction decreases. No, remember Hess's law cycle. Total enthalpy change is independent of route taken. P change is independent of route taken. Therefore, the enthalpy change for the forward reaction will not be affected, won't decrease. Which line shows that the volume of hydrogen produced changes with time? So it says line X, which is here, for C, shows the volume of hydrogen produced changes with time. Magnesium reacts with this much of HCl. To find out the moles of that, 30 divided by 1000 times by 1.0, 0.03. Now that's for X, which is at C. Now we use 20 divided by 1000 to find out the moles of this one. When the reaction was repeated times by 2.0, 0.04. So which one's going to be 0.04? Well, that's 0.03. There's 3 of them. Therefore, it increases by 0.01 each time. That's 0.02. That's 0.03. Therefore, this one's going to be 0.04. So the answer is going to be B. So yeah, once you've recognized this type of format, you can calculate moles, and then the increase is by 0.01, therefore it's B. Which statement is not correct? I really like to say false. Which statement is false about the pollutant sulfur dioxide? It can be removed from car gas exhaust gases by catalytic converter. It can be removed from power station flue gases by reaction with calcium oxide. That is definitely true. I remember that. It can cause respiratory problems. Yes. It can cause acid rain. Yes. Causes acid rain, which causes respiratory problems. Causes acid rain / respiratory problems. Can be removed from car exhaust gases by catalytic converter. No, that is nitrogen. It's not sulfur dioxide, that's for sure. I think it's nitrogen dioxide or something. What is the percentage atom economy for the production of ethanol from glucose? Final question. Percentage atom economy is MR of desired products over MR of all reactants. So what desired products? Percentage atom economy for the production of ethanol. So ethanol is my desired product. So it's going to be ethanol, which is 12 plus 12 plus 5 plus 16 plus 1. We also need to take into account of the moles. So what is 12 plus 12 plus 5 plus 16 plus 1? It's 46. So it's going to be 46 divided by MR of all reactants. In this case, reactants is glucose. 12 times by 6 plus 12 plus 16 times by 6. 180 times by 100, right? 46 divided by 180 times by 100. 25.6%. No, we need to include the moles. Percentage atom economy, need to include the moles. And obviously there's 2 moles of ethanol, so we need to times that by 2. 46 times by 2. And if we do that, then we should get 51.1%. Therefore, C is the correct answer. So remember, percentage atom economy, need to include moles, and the only way you know that is just by reviewing your notes, I guess. You need to include the moles. And obviously, formula MR of desired products, MR or divided by MR of all reactants times by 100, and that's the end of multiple choice questions.